Hi guys, here's section 5.3. I'm going to start with example number 1. We're going to be solving trigonometric equations. When we solve equations, we're really looking, we want to boil it down to an equation that looks maybe something like this here. Sorry, this graph is so blurry, but it's blurry when I upload it, and then when I stretch it, it makes it even worse. But you should know what the graph of cosine x looks like. And basically what we want to do is we want to get this to where it's one trigonometric function is equal to a number, and then we want to know where is it equal to that number on this graph. So for example, this cosine x equals 1/2. Well, this is my graph of cosine, and it equals 1/2 here at pi over 3, and it equals 1/2 here at 5 pi over 3. And then if I keep going, it equals here again at pi over 3 plus 2 pi, 5 pi over 3 plus 2 pi, 5 pi over 3 plus 4 pi, so on. And then also minus 2 pi, minus 4 pi, minus 6 pi, so on and so forth. So that's basically the gist of what we're doing. Because cosine has a period of 2 pi, when we're on our unit circle, there are two different places where it's equal to pi over 3, so that's why I have two different answers. So let's apply just that part to example 1. So, like I said, my goal here is to get the sine x by itself. So I'm going to move anything that has to do with x over to the other side, and my number is going to go to the right side. So 5 sine x minus sine x would be 4 sine x. Over here is equal to -2. Still don't have sine x by itself, so I'm going to divide off the 4. And so sine x is equal to -1/2. So then I'm going to ask myself on my unit circle, so back to my unit circle, where is sine? Remember, sine is y, cosine is x, tangent is y over x. All right, so when I want to know where my unit circle, where is my y value equal to -1/2? And so that's going to be at two places. One of them is over here, and one's over here. Pretend like this is a nice even graph. So over here would be at 7 pi over 6 and at 11 pi over 6. Those are the two places where my y value, so if I put in my point there is positive square root of 3 over 2, -1/2. So in other words, at these 2 points, my y value is the -1/2. So my solutions are 7 pi over 6 and 11 pi over 6. So if you've forgotten about your unit circle, make sure you go back and memorize it or have one handy. I really encourage you to memorize it and keep challenging yourself to solve these in your head. All right, so that would be the two places inside the period. So that, for example, that would be like this point and this point for this problem. But keep in mind, I said, oh, but wait, we'd add 2 pi, we'd add 4 pi, we'd add 6 pi. So all the coterminal angles are going to be plus 2 pi n. Why 2 pi n? Because my period for sine, cosine, secant, and cosecant is all 2 pi. And this is true when n is an element of all integers. So in other words, this is true for every n, where n is 1, 2, 3, 4, 5, 6, or -1, -2, -3, -4, -5, -6, or 0. 0 would give us our two original ones. So this is the solution I'm looking for. When it's sine, when it's cosine, when it's secant or cosecant, we're going to have 2 pi n added each time, and we should have two solutions because we're going to have two of them here. All right, tangent's a little different, but we're going to set it up the same way. I'm going to get tangent by itself, so I'm going to subtract tangent, and then I'm going to add square root of 3. So 2 tangent minus tangent would just be 1 tangent, and it's going to be equal to the square root of 3. Now remember, tangent was a little different when we graphed that one. It was split across 0, and my period, we had asymptotes of these two guys, right? And our period then was between -pi over 2 and pi over 2, and that's a length of pi. So period for tangent is pi. So I'm only going to have one solution here, and then to that solution I'm going to add pi to it every time. So I want to know where on the unit circle is y over x equal to square root of 3. And to find that, I'm going to look on my unit circle, and I'm going to look where y has got a square root of 3 in it, and see if the bottom part will boil out to 1. So if you look on your unit circle at pi over 3, this is my best guess. If I look at pi over 3, my point there is 1/2 square root of 3 over 2. So what would y over x be for this one? The square root of 3 over 2 divided by 1/2. To solve that, we're going to multiply by our reciprocal, right? Or to simplify it, not solve it. So to simplify this compound fraction, I'm going to multiply by the reciprocal of the denominator. And when I do that, the 2's cancel, and I just get the square root of 3. So this indeed is the one that we're looking for. It's supposed to be a check mark. So good there. And then for this guy, we're going to add pi n. Why pi n instead of 2 pi n? Because the period of tangent is pi. So the other place on the unit circle where this is true is at 4 pi over 3. And I was asking you today in class, well, what's pi over 3 plus the pi n? Plus pi. Well, we'd have to find a common denominator, which would be 3, which means I have to multiply the numerator by 3. And I've got pi plus 3 pi, that's 4 pi over 3. That's the next place on the unit circle where this is true. So just adding pi over n instead of 2 pi over n will cover this guy here and all the ones that are coterminal to it. All right, on to the u try. So the point being for this basically is if you got sine, secant, cosine, cosecant, you want to add 2 pi, and you should have 2 different solutions. If you have tangent, you're just adding pi each time, and you're typically going to have 1 solution. All right, look at the u try. Here I'm going to subtract 2 sine x, so 4 minus 2 sine x is 2 sine x. And then I want to get rid of this 2, so I'm going to divide by 2, and I get sine x is equal to square root of 2 over 2. So where on my unit circle is sine x, or is y, square root of 2 over 2? And that would be here and here at pi over 4 and 3 pi over 4. So x equals pi over 4, x equals 3 pi over 4, and for both of these guys we're adding 2 pi n, where n is an element of the integers. All right, that's it for example 1. Come back and I'll have a video for example 2.